Hi friends, welcome to our channel Making Engineering Mathematics Easy. I am Dr.V.Choudri, Assistant Professor, Department of Mathematics, working in RMD Engineering College. In our previous videos, we have discussed how we used integration techniques by direct method, substitution method and integration by parts. In this video, I would like to share my ideas how we use the integration techniques by partial fraction. Integration by partial fraction is one of the techniques which transform the given integral into some other simple form. That simple form may be obtained by direct method and substitution method. Mostly we use some formulas only for integration by partial fraction. These are integral dx by ax plus or minus b. You know the direct answer 1 by a log of ax plus or minus b. Second, integral dx by ax plus or minus b whole power n. The direct answer 1 by a ax plus b whole power minus n plus 1 divided by minus n plus 1. Third, integral x into dx by x square plus a square. Clearly, this is the substitution form because denominator x square plus a square. The corresponding differentiation is x, that is in numerator. So that answer 1 by 2 into log of x square plus a square. Fourth, the common one is integral dx by x square plus a square. Answer 1 by a tan inverse of x by a. Actually, this formula will be discussed later. This is come under trigonometric substitution. Let us start from the basic example. Integral dx by x minus 2. You know the result? Log of x minus 2. Integral dx by x plus 3 whole square. You know the result? Minus 1 by x plus 3. Third is integral dx by x square plus 25. As per the result, 1 by 5 tan inverse of x by 5. Look at all the terms. X minus 2, x plus 3 whole square, x square plus 25. If all comes individually, you know how do we evaluate this integral? Now my question, if all comes together, what you will do? See the denominator, all the terms are factorized properly. So better thing is we apply partial fraction. So what is partial fraction? Start from the basic concepts. If the denominators are non-repeated linear factor, 1 by x plus a into x plus b. See how do we partial this one? A by x plus a plus b by x plus b. Second, repeated linear factor. 1 by x plus a whole square into x plus b whole square equal to a by x plus a plus b by x plus a whole square plus c by x plus b plus d by x plus b whole square. Third form is quadratic factors. 1 by x square plus a square into x square plus b square equal to ax by x square plus a square plus b by x square plus a square. The same way for second also. Now we come to the given example. Integral dx by x minus 2 into x plus 3 whole square into x square plus 25. First, as per the non-repeated linear factor a by x minus 2. Second factor is repeated linear factor. So b by x plus 3 plus c by x plus 3 whole square. Third one is quadratic factor. So that dx by x square plus 25 plus e by x square plus 25. Okay. Now we are applying integration on both sides. So what will come? A into dx by x minus 2 plus b into dx by x plus 3 plus c into dx by x plus 3 whole square plus d into x into dx by x square plus 25 plus e into dx by x square plus 25. Now the given integral comes the simple integration. Now we apply the direct method and substitution method. You may get the result. Let us see another example. Integral x power 4 minus 2x square plus 4x plus 1 divided by x cube minus x square minus x plus 1. Look at this numerator and denominator. What did you observe? Clearly, the degree of the function in numerator greater or equal to degree of the function in denominator. This is called improper fraction. You know the concept, how you convert the improper fraction into mixed proper fraction by the formula quotient plus remainder by divisor. Now take the integrand. See, put the dividend into this one, x power 4 minus 2x square plus 4x plus 1. and the divisor x cube minus x square minus x plus 1. We start from the quotient x. What is the answer? X power 4 minus x cube minus x square plus x. Subtracting from the previous one, x cube minus x square plus 3x plus 1. Now the only one chance, take the quotient plus 1. So x cube minus x square minus x plus 1. Cancelling these two, you may get the remainder 4x. Now use the formula quotient x plus 1 plus remainder 4x divided by divisor x cube minus x square minus x plus 1. Now apply integral on both sides. Integral x plus 1 plus 4x by x cube minus x square minus x plus 1. Now first two terms are very easy. We can integrate directly the answer x square by 2 plus x plus integral 4x by the x cube minus x square minus x plus 1 can be written x plus 1 into x minus 1 whole square. Now this integral will be evaluated by partial fraction. Applying the partial fraction for the integrand 4x divided by x plus 1 into x minus 1 whole square equal to a by x plus 1 plus b by x minus 1 plus c by x minus 1 whole square. Now take LCM on both sides. What do you get? 4x equal to a into x minus 1 whole square plus b into x plus 1 into x minus 1 plus c into x plus 1. What happened? We'll put x equal to 1. You may get c value equal to 2. When you put x equal to minus 1, you may get a value equal to minus 1. Then if you put x equal to 0, you may get b value equal to 1. Successfully, we found that all the a, b, c values. Then we come to the integral x square by 2 plus x. Already we found that. Now as per the partial fraction, a into dx by x plus 1 plus b into dx by x minus 1 plus c into integral dx by x minus 1 whole square. Now using the direct method, you apply the result. Now we try to solve the following problems for better understanding. The first problem, integral 3x square plus x plus 4 by x power 4 plus 3x square plus 2. Look at this problem. Clearly direct method is not possible. Check with the substitution method. Denominator x power 4 but numerator x square. So substitution method is not possible. Clearly integration by parts also not possible. Then go for another method. Look at this denominator. When we rewrite this denominator into x square whole square plus 3x square plus 2. Now the denominator easily factorized by x square plus 1 into x square plus 2. Now we apply the partial fraction. A into x by x square plus 1 plus b into 1 by x square plus 1 plus c into x by x square plus 2. Finally d into 1 by x square plus 2. Using partial fraction, you may evaluate this integral. See the second problem, integral dx by root x minus cube root of x. Just we rewrite the integral into integral dx by x power 1 by 2 minus x power 1 by 3. Clearly, direct method is not possible. Using substitution method, in the x power 1 by 2, x power 1 by 3 to convert into integers by t power 6 equal to x. So that x power 1 by 2 equal to t cube, x power 1 by 3 equal to t square. Now we differentiate t power 6 equal to x. What do you get? 6 into t power 5 dt equal to dx. Therefore, the given integral becomes 6 into integral t power 5 dt by t cube minus t square. Taking t square common from denominator and cancel with the numerator, the given integral becomes 6 into t cube minus t minus 1 dt. This is the form improper fraction. Using partial fraction, you may get the result. Third one, integral secant square t dt divided by tan square t plus 3 into tan t plus 2. Clearly, direct method is not possible, but we have tan t, the corresponding differentiation secant square t also present in the integrand. So we may apply the substitution method. Choose x equal to tan t, dx equal to secant square t into dt. Therefore, the given integral becomes integral dx by x square plus 3x plus 2. Now the substitution method leads to some other form. Now the denominator easily factorized by x plus 1 into x plus 2. Therefore, using partial fraction, you may get the result.